So the difference between molarity and molality is that molarity is moles of solute per liter of solvent, and molality is moles of solute per kilogram of solvent. And then for number 13, calculate the percent by mass of benzene in a solution containing 14.2 grams of benzene in 28 grams of carbon tetrachloride. So I have done the math here on my paper, and so you can see that I took the grams of solute on the top, and then I put grams of solute plus grams of solvent in the bottom, divided the two and took it times 100 to get 33.6%. For the molarity problems, you can see the work that I've done. Remember that molarity is moles per liter, so if you're given grams, you have to change it to moles, and if you're given milliliters, you have to change it to liters by moving the decimal. So here on the paper, you can see my work for the molarity. So if you have any questions about the molarity ones, come and see me about them. Then number 15 is a dilution problem, so you need to know how much stock solution you're needed to make your one you want to make. And so it's M1V1 equals M2V2, and you can see my work right there. It's okay to use milliliters for that one. The answer will come out in milliliters. And then number 16, what do colligative properties depend on? They depend on the amount of solute. And then 17, 3 colligative properties would be vapor pressure lowering, boiling point elevation, and freezing point depression. Number 18, why a solution has a higher boiling point than a pure solvent? Well, we had that slideshow and you could see that solute particles kind of block the surface of a liquid, and so when they do that, they cause less particles to be able to go to the gas phase, causing the vapor pressure to be lower. The definition of boiling point is that vapor pressure has to equal atmospheric pressure. But when your vapor pressure is lowered, it takes it a longer time to get to the atmospheric pressure, and so it causes an increased amount of energy to get it to that point. And that increased energy is increased temperature, causing a higher boiling point. So number 19, why does a solute affect the freezing point of a solution? Essentially, the solute gets in the way of the attractive forces that form the solid. Number 20, explain why the experimental procedure is incorrect. I made a 1 liter of 1 molar NaCl solution. To do that, dissolve 58.5 grams in 1 liter of water. No, you can't do that. You have to dissolve your grams of sodium chloride in a small amount of water and then fill it up to 1 liter. If you take 1 liter and add your solute, then you're going to have a volume of over 1 liter. So you can't take 1 liter and add your solute. You have to add your solute and then fill up your flask to 1 liter. And then for a lab, you need to dilute a stock solution of hydrochloric acid. The stock solution is 6 molar, but you need 150 milliliters of 0.5 molar acid to use in your lab. Explain the procedure you would use. Well, it's a dilution problem, so M1V1 equals M2V2, no problem. Solve for V1 and I get 12.5 milliliters. But in order to make it, what you're going to have to actually do is take 12.5 milliliters of your stock solution, add it to a flask, then fill your flask up to 150 milliliters, and then you'll have the solution you need. For 22, you add 110.06 grams of copper sulfate to 500 milliliters of water and start seeing solid pieces on the bottom of the flask. What happened? It became saturated, and so the extra was falling to the bottom. So how many moles of it dissolved in the water? You take your amount of grams and use your molar mass to find out your moles. So you change grams to moles, that's how many moles are dissolved. And then the molarity, we know how many moles, and we know that we dissolved it in 500 milliliters, but we have to change it to liters to get molarity, so 0.5, and then you just solve 1.40 molar. For 23, a solution has reached its saturation point of 5.640 molar in 500 milliliters of solution. And your first question is how many moles are in the solution? Well, if you know molarity and you know the amount of liters, then you can solve for moles. Molarity would of course go out here, M equals moles over liters. So molarity here, your amount of liters here, and solve for moles. So you're going to multiply these two together to get 2.82 moles. And then the amount of grams of cobalt nitrate that are in the solution. Take your moles, change it back to grams using molar mass, and you have approximately 516 grams in the solution. I apologize for the messiness, you guys. I was in a little bit of a hurry this morning and technology was not cooperating. I hope this was helpful, and I hope that you study hard for your test tomorrow. Good luck.